be the facilitator for the statistics workshop that we're gonna have this semester, starting today. So today will be our first session. Bulelwa will be my left hand lady, my coordinator for the session. So if ever maybe I might have missed your hand, if it was up, then I'll appreciate Bulelwa to then just make note of that and alert me when such cases do happen. Because when I start these facilitate sessions, I get so much interested and intrigued to them that I don't get to notice some other people's hand up, especially because we're doing these sessions online. I'm currently a doctorate candidate at the University of KwaZulu-Natal in statistics, um, where my main interest is based on biostatistics. So welcome. Hopefully you guys are gonna have a really fruitful journey with me in making you guys understand just why is stats important and what to expect when you take these statistic modules. So the first thing maybe then I'd like to elaborate on is why is it stats important, right? Oh, before we start, because this is not a lecture, it's just a workshop, a facilitated workshop. So I wouldn't mind if maybe you interject me if ever you'd want to add something, or you want to make a comment, to please switch on your mic, speak, or else just raise your hand. Then Bulelo will alert me on that. Then you can unmute your mic and speak, right? Because I want us to have an interactive type of a session where I also gain some insights on you. I also get to understand what you guys don't understand before I maybe go over many slides, only to find that you guys don't understand me. Or if ever maybe also I'm not audible enough, Bulelo, please also alert me on that before I go over through many slides. Okay, so the first question is then is why is stats important, right? And what is statistics? Okay, so that's a very interesting question for me because with my understanding is that you can only learn what you're interested on, right? So let me just put some interest in you guys. Okay, so statistics to me is like a branch from mathematics, right? Now, to put some context in this, people often say numbers don't lie, right? But with me, I beg to differ when it comes to that. I feel like numbers do lie if they are being interpreted incorrectly, right? Now, that's where stats comes in. Stats is like a big brother of math. Now, let me make an example of this. Let's say, for instance, you've got three guys on a Friday at a bar, right? These guys are having their drinks, everything is nice. They just finished work, right? They work on the same company. Two guys from these three guys work for the same department. This one guy doesn't work for the same department as these two guys, right? Then this one guy from these two guys be like, hey guys, listen, I'll pay for the drinks. Drinks are on me because I get paid 10,000, right? Then this third guy who's not part of that department becomes like have this sort of shocked look on his face. Then this other guy which work with this guy on the same department be like, but I get paid 7,000, right? So the third guy who's watching these two guys, the other saying 10,000, the other say 7,000, having this shocked look, is like, this guy, why is this guy lying about his salary, right? Because this third guy, his assumption will be like, okay, they're from the same department, so that means they get paid the same amount, right? that what this guy is thinking. So in this guy's head, numbers now suddenly they're telling a lie because this guy is saying 10,000. This guy is saying he's getting paid 7,000, right? Then around that myth or this conversation, the manager comes through on the same bar. He's like, "Hey guys, I see you guys are having a little party here. I wanted to come join you guys. What's happening?" So this manager is the manager for these two guys, right? These two guys are sort of under this manager that just came in, and this manager is like, "Yeah, I mean, I see you also having some sort of um um interacting of words here. What are you guys talking about, right?" So this guy, the third guy, is like, "No, this other guy is saying he's getting paid 10,000, and this other guy is saying he's getting paid 7,000. To me, that's a lie." Then the manager put some elaboration, some interpretation into the story. Now, the manager is the stats. These two other guys, those are the math, right? So if the manager now start to then put some interpretation in this, in explaining the two descriptives of the job descriptive rather of these two guys, that this one, yes, get paid 10,000, that's true, because the job description of this one is a bit more than this other one. And obviously this guy from time to time will need to also work overtime because of his job description, hence the high salary than this other one, right? So with just that course, with just that narrative story that I've just explained to you guys, can you see that numbers can only be true if they are being interpreted correctly? So with just this little story that I've shared, I'm trying to put some interest in you guys that it is important to understand that numbers can only be true if interpreted correctly, and they can only be interpreted through statistics. With that being said, welcome to our first session for the stats workshop. Okay, hopefully you guys can see my screen. So today's session will be based on chapter 1 and chapter 2, right? So my chapter 1 is based on understanding just the terms we use in stats. Then my chapter 2 is based on the descriptive stats. Now, from understanding the terms we use, how do we then go about understanding of organizing the data? How do you then go about differentiating on tools to use for analyzing different types of data that you might have, right? That's chapter 2, right? We're only going to be looking at those two chapters today. Okay, so this is my first slide, and I hope they did share with you guys all the slides that we're going to be looking at on today's session. I also gave the stat department, whoever is responsible for the workshop, to also give you guys just some sort of content of what our sessions will be based on throughout all our sessions, right, from chapter 1 up until chapter 9. Okay, so without any waste of time, then let's just look at. All right, Bulero, did my slide change?
Mr. Ngogo?
Bulelo, did it
Yes, I'm here.
change? Did it change?
Please try again. Let me say. Oh, yes, they're saying it did.
It did. Okay, perfect, perfect, guys. So yeah, statistic is the methodology used in drawing meaningful information from the data set, right? Did you see the manager there came to the bar, draw some useful information from what the conversation was about? From that, he then elaborated and interpreted what these three guys were talking about, right? So that's stat for you. So stats is set of values or response obtained when gathering information on some issue of interest, right? So We then going to be looking at a set of numerical values. That's your data. We also going to be looking at measures of description obtained from that data set. So go to slide 2. So stats is differentiated between two ways. You've got something referred as descriptive statistics. You also have something referred as inferential statistics, right? Where if you look at descriptive statistics, this is where you dealing with the collection, the organization and summarization and the presentation of the data, right? Then if you're looking at inferential statistic, this is where you're looking at involving using samples. It involves using samples where these samples you take from the population. Then from the samples that you have, you then want to make conclusions. What you're doing by doing that is referred as inferior statistics, inferred statistics, where you have a population. From the population, you take your sample. From that sample, you then want to make conclusion based on the whole population. But you can just put that aside for now, because this is what we're going to be looking at from chapter 7 to 9. Then under descriptive statistics, we're going to be looking at that today. All right. So speaking about data can be collected from a population's state of view, or it can be collected from just a sample, right? Let's look at um, the definitions of what a population is and what a sample is. A population, this is all the items with the same characteristic of interest, which we're going to denote as size n. Now, an example of data that is collected based on the whole population has to be the census. I'm sure everyone here knows what a census is, or a census study rather. A census is a study of all items in the population. So it doesn't really have to be people, right? In most cases, we get to understand census from collecting data from people in South Africa only. But a census can come from collecting data from all the animals in South Africa. That's also can be a census study, right? It doesn't mainly mean census means collecting data from people. Okay. Now the problem with census is that it can be very much expensive to collect data from the whole population. It can also be, I mean, somewhat not really practical. It takes a lot of time, right? Now, what do we then do? Because it's expensive, it's not practical, it's time consuming. Does it mean we stop with the study? Does it mean, what we're interested on, it's some type of information we'll never be able to find? No, we have solutions from these three things that can be problem when collecting data from the whole population. One solution is collecting the sample from the population, right? Now, what is a sample? A sample is a subset from the population, right? Now, uh yeah, it's a subset from the population, and we denote that as a subset or that sample as small letter n, right? Remember, the population is denoted as capital letter N. All right. Now, from that sample that you've calculated, you will then obviously be interested in generalizing that sample to the whole population. Because remember, why did you collect the sample? It's because the collecting the information based on the whole population, it was expensive, it wasn't practical, it was time consuming, right? Then you opted on taking a sample. Now, but you're not interested in just the information from the subset of the population or just the sample. You interested in the whole population. So from your sample, you want to generalize or get some insights and infer your sample to the whole population. Okay. All right. So these are just elaborated definitions of the population and the census. You can just go through this on your own, but what I'm interested on is the examples, right? Let's look at the examples. So if you look at the population, now the first example that comes up is that all balloons made at a particular factory, all balloons, right? All balloons made at a particular factory, all babies in KZN in hospital. The word all means you're looking at every item within that factory. You're looking at all the babies in KZN, all the items, which is in this case are the babies in the hospital. This all elaborate that what you're interested on or what you're referring on is the population, right? Let's look at the census. I mean, I've already made an example of a census with you guys where we go, I mean, find information, collect data from each and every household, each and every member within a household in South Africa. That's what we refer as a census study, right? Now, let's look at an example of a sample. A sample is a subset from that population, right? So it means from the population that you have, you just want to take or do a data collection just from a particular interest of character from your population, right? So in this case, the example is that every 20th balloon made in a particular factory, right? From that factory, we only interested in the 20th balloon that is created, right? From that factory, from the population. Okay. 10 babies chosen at random. From those all babies from the population, we're only interested in 10 babies. Okay. So that's a sample example. Now there's something referred as a parameter and a statistic, right? Remember, we talk of population and a sample. If everything, anything rather, is calculated based on the population, everything that is calculated based on the population is referred as a parameter. Everything that is calculated based on the statistic is referred based on the sample is referred as a statistic, right? Now, how I sort of help myself memorize this or not to forget this, I look at these first letters from these words, right? P for population, parameter, population, right? S statistic, S sample, right? All right. All right. Now let's look at notations we use when it comes to statistic and parameters, right? Um, I mean, what you can calculate from the population or from the sample is a lot of things, but I want us to just look at these main sort of mostly use statistic measures, right? You've got your mean, you've got your standard deviation, you've got your variance, you've got your size, you also have your proportion, right? Now, from a statistic, can you guys see my cursor? Can you see it, Bulelwa? Is Bulelwa there? Anyone, can you guys see my cursor? I'm moving it around, so I want to make use of it. So I want to just make sure that you guys see it.
I
No, we
can't
can't
s- I
see.
can't see it from my side, Mr. Mulu.
No.
Oh, you can't see my cursor.
No. I've
Oh,
been trying to look while you are calling me, but I can't see.
oh, okay. Okay, let me try share my screen differently. I wanna see something. Can you see it now?
Yes, yes,
Okay,
yes.
perfect, perfect. Because I want to use it in pointing out some of the things, right? So yeah, your statistical measures that we mostly make use of is either your mean, your standard deviation, your variance, your size, and your proportion, right? Now, from the mean, if your mean was calculated based on the sample, then you denote it as X bar. Otherwise, if it was calculated based on the population and is referred as a parameter, you denote it as a mu. If it was calculated, if your standard deviation was calculated based on the sample, you just denote it as S. Otherwise, if it's from the population, then you have this some sort of nice shape here. What do you call this? Is it what do you call the sigma? Is it sigma? I'll get back to that. But this is the notation we use. Then on variance, instead of writing S just S, you need to have a squared here. So it's S squared. And also from the population parameter for variance, you have this with the square, right? Now a size, like I've explained to you guys, that a size of a sample is denoted as small letter n, and the size of the population will then be denoted as capital letter N. You also have something referred as a proportion. If your proportion was calculated based on a statistic, based on a sample, which will then be referred as a statistic, you then denote it as P hat. Otherwise, if it's from the population, you just write your P. Okay, right. Now, y- you have something known as a variable. A variable is a characteristic that can assume different values, right? From a variable, you can have two types of variables, right? So now we're looking at data. While I'm explaining these terms, what must come into your head is data, numbers, right? So that data, I'm now calling that data that you've collected, I'm calling it a variable. That variable can be assumed of different values, right? Now, those values can be either discrete or continuous. If you talk of a discrete variable, this is a variable that assumes a finite or countable number of possible values, right? For instance, if you look at you guys here, right, in my class, in my session, there's only 25 of you guys. We can't have 25.6 of you guys. So you guys are countable. You guys are finite. So it means you guys start from having zero participants of my session to 25 people who attended my session. So you guys are being labeled as a discrete variable, right? Because you are countable, you are finite. We then have a situation where also values are referred as being continuous, right? Now, what do we say when why do we say a variable is continuous, and when do we say a variable is continuous? This is when you're talking of situations where you're looking at values and these values are infinite. So these values don't stop, don't have some sort of what's this, a cut off value, that these values start from here, they end to that value, right? Like for instance, if you look at your age, your age, you don't have some sort of a cut point age that on this age I'll probably uh die, or I'll probably um I mean, this will be the last age of myself living in this beautiful earth of ours, right? So you don't have that. So age is then referred as continuous variable. Okay. Your weight, the weight of the cars at a particular factory, weight. If you look at weight, um, weight, you can never have some sort of a cut off value. If you're looking at weight, that okay, weight, it's the cut off of weight, every car should have a cut off of weight to this value. right? You don't have that. So hence, if a variable is referred, it doesn't have a cut off a point, then that variable is referred as continuous. It's continuing. It doesn't have a cut point. Okay. So these are more examples. You can just, because you have the notes, you'll go through these examples yourselves. Now, interesting part. Remember, when I was talking about variables, these are values. These values can be distinguished between two characteristics. It's either these variables are discrete or these variables are continuous, right? These are values, right? Now, let's now look at another way to class these variables. So the same variable, well, we've learned that it can be distinguished between two ways. It's either discrete or continuous. Now, the same variable can also have a measure of scale, right? Let's look at these measurement of scales. Now, these variables, this data can be distinguished between two characteristics. It's either you have a data referred as qualitative data, or you have quantitative data. Now, if you talk of qualitative data, these are variables, right? Which are non-numeric. Quali, there are no numbers in this data. So it's a qualitative data. It assumes non-numerical values, right? Then you have quantitative data. This quantitative data, this type of data is a data that include numbers. This is a variable that have numerical values, right? It has numbers. So that type of data is then referred as a quantitative data. Otherwise, if it's just names, so then that data is then referred as qualitative data. Right. These are more examples. Let's just go through these nice examples we have here. Right. Different holiday destination in South Africa. So it's either I've never been to Cape Town, so I'd want to go to Cape Town one day. I would like to also visit you guys in Pretoria. I've never been to Pretoria. You see, these are different holidays destination within South Africa. Now, when mentioning these locations that I want to visit, there are no numbers assigned to these locations. So that is referred as qualitative data. Let's look at an example based on quantitative data. The length of stay at a holiday destination, right? I've never been to Cape Town. I want to stay the whole month there, right? Now, for the fact that I've included, I'm talking about now the number of days, number, right? I will stay 30 days. That's the whole month. It means then I'm talking about now the data, the number of months, which is then referred as quantitative because of the fact that I've included now a number. Remember, quantitative data is numerically inclined, it's numerically referenced, right? Quanti. Okay. This is a nice table that I've designed for you guys to just make things easy for you, right? You've got a variable. Now, this variable can either be continuous or discrete. From that variable, which is continuous or discrete, it can be of qualitative or quantitative, right? Qualitative, non-numeric, the measurement scales that you can have out of the data that is referred as qualitative, which have non-numerical values. It's either it's nominal or it's ordinal. Otherwise, if it's a quantitative data, the measurement scales that you can have out of the data, which is referred as being quantitative data, which can be either continuous or discrete, it's either you have interval scale or ratio scale, right? Let's look at this type of data: nominal, ordinal, interval, or ratio, right? Nominal scale. It comes from qualitative data. What are the properties of a nominal scale? A nominal scale, this is a data that can be put into categories. There is no natural order to categorize this data. Categories cannot be ranked one better than the other, right? Example, if we look at profession, if we look at brands of bread, if we look at gender, right? Now, if you look at a profession, um, in a company, there are different types of profession, right? These profession are not number sort of there is no number reference to a proportion profession, right? So they are of qualitative data. You also have brands of bread. These brands of bread are of also qualitative data. Gender, whether you male or female, right? There is no number in reference to these characters. So that with that, this is your qualitative. From that data, you can then tell that this is a nominal data because this can be put in a category. There is no natural order. There is also no ranking between these examples that we've just labeled just now, right? Then we have something referred as an ordinal scale, which also comes from a qualitative um, data. Now, what then make a variable be of ordinal scale? It's because that data can also be categorized like a nominal, that's fine. Then also that data, there is natural order to the categories, right? Remember, in nominal, there is no natural order. Here, there is natural order. Categories can be ranked, right? Now, let's look at some nice examples on that. Responses to the statement, shopping is a social experience for me, whether the options are where the options are agree, unsure, disagree, right? Responses to the statement, shopping is a, so this is a question. So shopping is a social experience for me. The options, it's either you say agree, unsure, or you disagree with that. Grades are A, B, C, right? Data can be categorized A, B, C. There's natural order. You can't have A, C, B. You need to say A, B, C. Agree, unsure, disagree, right? Then this can be ranked. So you'll have someone who's saying they agree, you'll have someone who will say they unsure, you'll have someone who will say they disagree with the statement, right? That can be ranked. Okay. We then look at quantitative data. From quantitative data, you've got two types of measurement scales, which is ratio and interval. Let's look at the interval scale. Now, the properties of something being referred as an interval scale is the first thing, it needs to be quantitative. That's the first thing of character of a variable for it to specify itself as being an interval scale, right? It needs to be a quantitative data, right? Properties is the data can be ordered, it can be ranked where difference are also meaningful. There is no meaningful zero, right? Ratios are meaningless. Let's put some context into this. Let's look at the example. Interval scale will look at temperature, right? The difference between 100 degrees Celsius and 90 degrees is the same as the difference between 90 degrees and 80 degrees. Is that true? Let me ask you guys. So this is a question I'm asking you guys. So the difference between 100 degrees and 10 degrees is the same as the difference between 90 degrees and 80 degrees. Let's go back to the definition. Right. Does that make sense to you guys? Is it true? Does it, you know? So I'm asking you guys a question just to understand if you guys are following. The difference between 100 degrees and 90 degrees is the same as the difference between 90 degrees and 80 degrees.
Yes.
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 Yes, perfect. So you see, if something is referred as an interval scale, the difference between two variables will make sense, right? Let's look at ratios. Ratios don't make sense. 20 degrees is not equals to 2 times 10 degrees. 0 degrees does not mean there is no temperature. Zero is an actual temperature. Therefore, there is no natural zero. Right. Let's look at another example. The following values are years of birth of 10 random chosen actors. The first thing you look at these years is they are quantitative. So for the fact that these are quantitative, it means that these are interval scale, right? Now, if you look at 1993 minus 1968, this is equals to 25. So the difference between values makes sense, right? This means that the person who's born in 1993, as compared to someone who's born in 1968, there's 25 years of difference there, right? The actor born in 1993 is 25 years younger than the one that was born in 1968, right? This just elaborates the difference. So it makes the difference makes sense. The year zero doesn't mean there was no year. So zero, if you put zero, it also zero has some sort of definition in terms of year, right? So year 2000 does not equal 2 times year 1000. Okay, I'll give you guys some nice exercise just to see if you guys are following through the different measurement scales, the types of variables, either whether is it discrete or continuous. So I'll give you some nice exercise on that. All right, so the difference between ordinal and interval level of measurement. Ordinal is when you're looking at difference between outcomes values do not make sense, the difference, right? Now in interval, the difference makes sense. So subtract one outcome or value from another, from one another, and see if it makes sense. All right, so this is a question. In what year were you born? You ask yourself that. In what year were you born? Consider the following statement. I believe that an increase in university registration fees will negatively affect the economy of South Africa. Tick the correct. Okay, before we go there, wait. Before we go there, sorry. Uh, okay. Yes. Right. uh, Tick the correct box, right? Whether you strongly agree with the statement, agree, naturally, disagree, strongly, neutral, or strongly disagree. Now, the year you were born in, This is a question. Is it qualitative or quantitative? I'm asking you guys. You can just unmute and say the answer.
Quantitative.
Quantitative. Good. Question two. Um, the answers that you're giving, are they quantitative or qualitative?
Qualitative.
Qualitative, right? Let's look at question one then. If you look at question one, um, what type of measurement scale is then question one? You said it's quantitative. What type of measurement scale is question one? Hello, you there? Talk to me. Anyone. So you've got something, your year, which you guys are saying this is a quantitative because of the fact that it's numeric from a quantitative variable. Then tell me, what type of measurement scale can can a year be?
Discrete.
Um, sorry.
Discrete.
Okay.
In, interval.
Why would you say so? Hope said discrete. Why would you say discrete, Hope?
Because it's countable, like no, not yeah, it's countable, so it's infinite. It ranges from 1 to infinity, so that's why the year you were born, you can calculate the number of years actually.
From yeah, I mean, if you look at the
It's a
fact that
specific year. It's
yeah,
not a. It's not a. It's not a. It's not a. What's this? It doesn't have It's not a scale actually. It's not a ratio or scale. So that's why it's continued. It's not. It's discrete, meaning that there's a. It's a set. It's a set year. It can't be 19 comma something. That's
okay,
that.
all right, all right. Thank you, Hope, for your answer. Who else have a different answer? Maybe from Hope. So my question is, if you look at the number, your year, the year that you were born, is it quantitative, you guys, or qualitative? You guys say quantitative. Now, the follow-up question was, what type of measurement scale can your year be? Now, remember, Hope, measurement scales, they can either be four types of measurement scales, right? It's either you'll have your ordinal scale, or you have your nominal scale, where these two type of scale come from the fact that a data needs to be qualitative, right? Regardless of the fact that they are continuous or discrete, right? Then you also have another two type of measurement scales, which is either ordinal scale or ratio scale. Now, before these scales can be quantified, the data needs to be quantity. It needs to be quantitative data, right? Now, look at your year, my sweet angel. If you look at your year, it's quantitative. You said this, right? And I agree. Your year, the year that you were born in, is quantitative. Now, your year can fall between two types of scale because it's quantitative. It's either can be a ratio or an interval scale, right? Now, so the answer to this question is that this your year can be an interval scale. It's an interval scale, right? It can't be a ratio. I'll tell you just now why it can't be a ratio, right? I did you get that, Hope?
Yes, I'm following. I'm following. I saw my mistake. Yes, I'm following. Can
All
you please
right.
explain the difference first between I missed that part where you were explaining the nominal and ordinal. Which one you said they are under quantitative variable.
What's
Um
your name? What? So your name is Hope, right?
yes, my name is Hope.
Hope. So your name is not a number. These are just letters, right?
Yes,
So that means your name is not numeric, right?
yes,
So that means your name falls under qualitative data, right?
yes.
Now, what's your two friends' name? Your
My
other two friends.
oh
Do you have friends?
yes, Palisa Lerato.
Palisa Lerato, right? So your guys' names are qualitative data. Your guys' names can only have two types of measurement scales. Which are those, Hope?
They can only be
Can only have two measurement scales. Which are those, Hope?
oh, I'm missing that out. That's where I'm lost.
Let's go back here. So you've got Hope, Lerato, and Palisa, right? Such
Mm,
beautiful names.
I wanted this slide actually. Thank you.
All right, cool. I'm saying your names are qualitative. So your qualitative names can only be of two measurement scales, either nominal or ordinal. Then you look at some things which are numeric, which are quantified, which are quantitative data. They can only have two measurement scales, interval or ratio.
Okay.
Yeah.
I got it. Thank you.
All right, perfect. So in this case, we also have qualitative data. This can be ordered. Strongly agree, agree, neutral, disagree, strongly disagree. There is natural order. So this is of qualitative data under the ordinal scale. All right. So this is just explaining what I was just explaining to you guys. Why is that interval? Why is the other one ordinal qualitative data? Let's look at ratio. Ratio it falls under quantitative data. For something to be referred as a ratio scale, the data can be ranked or ordered. Ratios are meaningful. There is a natural zero. Remember, um, in interval, the difference makes sense. So you also have some sort of interpretation when you have your zero. Then the values represent counts or measurements. Let's look at examples just to quantify what we mean, right? Let's look at weight. Weight is referred as a ratio scale. Why is weight referred as a ratio scale? Before weight is referred as a ratio scale, weight needs to be a quantitative um, variable. Then let's look at this example then. The following values are weight of parts made in a particular factory. You've got hundreds, 135, right? Never mind, the units are being given as kg, right? So 200 is equals to 2 times 100. What does this mean? The machine weighing 200 kg is double the weight of a machine weighing 100. So there's meaning in terms of the ratio of the given variables, right? A weight of zero means something has no weight. There's also a meaning in zero, right? Okay. Example two. A height of 2 meter is double the height of 1 meter. This ratio is meaningful, right? 0 centimeter means there is no measurement. The difference between 10 centimeter and 15 centimeter is the same as the difference between 15 centimeter and 20 centimeter, right? Now let's look at the difference between interval and ratio scales. If you look at a weight, 5 over 10 is equal to 0.5. So something that weighs 5 kg is half the weight of something that weighs 10 kg. The ratio makes sense. Visually, this is what it means. The line from 0 to 5 is half the length of line from 0 to 10, right? Let's look at temperature. Clearly, a ratio can be found, right? Remember, temperature is a what? It's an interval scale, right? But does it mean something correct? Does it mean something correct? Is a day that is 5 degrees Celsius half as hot as the day that is 10 degrees Celsius? That doesn't make sense, right? So if the ratio doesn't make sense, then it's an interval scale. So let me just give you guys a tip. Every time, every time I have something, right? I've got a variable which is quantitative. What I do is I always say it's a ratio scale. Then if the difference, if the ratio doesn't make sense, then I move it to become an interval scale. So the first thing I do, okay, it's quantitative, it's ratio. Now let me see, does it entitles the properties of it becoming a ratio? Does the ratio make sense of these two variables? If the ratio makes sense, okay, it's a ratio. If the ratio doesn't make sense, then it's an interval scale, right? Okay. That's how I always answer my questions when giving those type of questions that needs me to identify whether I'm having a situation which is where I need to define if data is of measurement scale, if that measurement scale, what type of data are we then looking at? You know, those type of questions. That's what I do, right? Same thing when it comes to identifying whether the data is nominal or ordinal. I first identify if it's a qualitative. If it's a qualitative, then I say it's ordinal. If it doesn't entitles characteristics of an ordinal variable, I then move it to becoming nominal. Okay, hopefully that helps. So this is what I was explaining. So even though a ratio can be found for temperature, the ratio doesn't make sense. I can see the difference, but why does it happen? Weight has a natural zero. Zero means there is none of it. Temperature is a man-made zero. It's just a reference point of significance. So you also need to use zero. If something is of ratio, there needs to be a natural zero. It must not need to be some sort of a zero that you sort of create for yourself, right? Okay. Now, these are example sort of exercise I'm giving to you guys before we finish chapter 1. Is classify the following: income per day of a bakery, types of ice cream flavors, levels of service satisfaction, number of people today. So the first thing I want you to tell me is this a qualitative or quantitative data? Then from there, I want you to tell me the type of measurement scale, whether is it nominal, ordinal, ratio, or interval. So number one a qualitative or quantitative data? Unmute yourself, shout the answer out.
Quantitative.
What?
Quantitative.
Quantitative.
Quanti, okay. Um, then if you agree with this, give me a reaction, a thumbs up reaction. If you agree with the answer, give me a thumbs up reaction. Okay, good. Number two, types of ice cream flavors. What is it? Is it a qualitative or quantitative? And
Quali
you
Quali.
quali. Why are you saying quali? Qualitative?
because it's not numbers.
Oh, it's not numeric. Okay. Okay. Please clap some hands for that good, nice answer. Um, then let's look at number three. Levels of service satisfaction. Is it quantitative or qualitative?
Qualitative.
Okay,
Yes.
Mapule, do you have a question?
Oh no, sorry.
Oh, you wanted to clap some hands, right? Okay.
Yes.
Okay, cool. So number three we said is what? Qualitative or quantitative?
Quali.
Quali. Okay, number four, what are we looking at?
Quanti.
Quanti.
Quanti
Why four are we saying quanti?
can be calculated.
It's
Can,
numeric. It's
yes.
numeric. I don't want you to say it can be calculated. I want you to say it's numbers. It's numeric, right?
Okay.
All right, cool. Okay, I'm happy that you guys are following. Now, tell me now the measurement scales of these four examples. If you look at number one, what type of measurement scales are we looking at there? Is it, you guys have said it's qualitative income per day, you said it's quantitative, right?
Yes.
All
Yeah.
right. Then if it's quantitative, it can only be two types of measurement scales. It's either interval or ratio. Then what type of ratio measurement scale are we looking at there?
Interval.
Ratio.
In-
Ratio.
yeah. Mm. So if is it ratio? You guys are saying it's ratio. If you agree with the answer, give me a thumbs up. If you don't, do we have a thumbs down here? This react thingy. How we don't have. Okay, so just say nothing then. Question. Do you have a question? Who's having a question? Bulera, is there someone having a question? Oh, you wanted to maybe clap. I don't know. Okay, cool. So you guys are saying it's a ratio. Why are you saying it's a ratio?
I think you can see the differences per day. So each day will have its different income,
Okay.
Also,
All
there's
right.
a natural zero.
and there's an weight to it. You can weigh
There's a natural zero. What's zero? Make sense of a
it.
zero. You can
It
have
means
zero income per day in a bakery.
Mm.
there is a possibility of them making zero income in a day.
Okay. I love this session. Okay, let's look at number two then. Um, s- Types of ice cream flavors. You guys said it's qualitative. Then, what type of measurement scale are we looking at here?
Nominal
Nominal.
scale.
It's nominal.
Nominal. Okay.
Yes.
Tell me, Tolofeto.
Yes.
Tolofeto, tell me, what's your favorite ice cream flavor?
Don't know. And I'll take vanilla. It's the easiest.
Yeah, I also love vanilla. Uh, okay. And that, what else? What other vanilla flavor do you know of?
It's chalk mint. And the other ice cream flavors, chalk mint, mm, strawberry, and something.
Mm,
Yeah,
mm.
there's a lot. There's different ones.
All right, cool. So if you go to an ice cream shop, These ice cream flavors, they don't put them in a certain order, they just put them there, right?
Yes.
Okay. So that means it is a nominal scale because there is no sort of order in
Mm,
putting these flavors, right?
yes.
All right, cool. Let's look at number three then. What type of measurement scales are we looking at there?
Nominal.
Ordinal.
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 Ordinary.
No. Ordinary.
Ordinal.
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 Busisiwe.
My
What are you
bad.
saying to me? Yeah?
My bad. I'm sorry. It's ordinal.
Ordinal. Good. Uh, okay. Number four, number of people here today in this session.
Ratio.
Yes. Yes.
It's ratio.
Yes.
Okay. Why is it ratio?
Is it not? Okay. Is it not interval? So there cannot be zero of us here. We are here most.
They can be. Can be.
No,
Cannot
no,
if
no.
But there's no man-made zero. There is a natural zero
There's
though.
no meaningful zero. So there's no way we can be zero in that class if we are already here.
Yes. Thank you, Busi. You can't. Don't confuse a natural zero and a man-made, right?
Mm.
If nobody is here, that zero is man-made or is it natural? I'm asking you guys. If nobody decides to join this session, is it man-made or is it zero? Is it
It's
natural
meant.
zero?
It's man-made.
Natural.
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 It's natural.
Hmm?
Natural.
It's natural.
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 But
It's
you are
actually
confusing
made.
us also. You are saying here and then you say, I don't know. But it's gonna be natural if you don't pitch for the class.
Okay.
I think it's ratio because it says represent a count. So we are counted 20 people. So I say ratio.
It's it,
Exactly.
it's man-made. You guys decide that you don't want to be part of
Yeah,
this
it's
session,
man-made.
Oh, okay.
right? Let's look at the answers. You got all quantitative, qualitative, qualitative, quantitative. You've got all that right. You also got all your ratios right, and your nominal and your ordinal. Can you guys just give yourself a round of applause for just being good students today? React
Okay, so
by
real
clapping.
quick,
Yeah, yeah.
real quick.
What's up?
On the number four, you put it as ratio, and you also, but you said the zero is man-made. So is it interval or ratio? Because if the zero is man-made, then it's interval, right?
So let's look at this number of people here today, right?
Mm-hmm.
Okay, firstly, let's go back to ratio, right?
Yeah.
This is properties of ratio, right? There
Yes.
is there is a natural zero, right?
Mm-hmm.
So there can be instances where no one is there, right? Zero makes sense if no one is there, it means that no one attended,
Yes.
right? Then let's look at interval. Interval, there is no meaningful of zero, right?
Yes.
So what how then we'll distinguish this is you need to put zero and try and make sense of zero. If there is no meaningful of zero, if zero doesn't make sense, then you will say it's an interval. But if zero makes sense,
Mm.
then it will be a ratio.
Okay, got it.
Yeah,
Yeah, makes sense.
yeah, I want us to make those distinguish. But what do we do first? The tip that I gave you guys is that if it's quantitative, we automatically we give it a ratio. Then if it's a ratio, we put a zero. Does zero make sense? If zero doesn't make sense, it's an interval. If zero makes sense, it's a ratio. Get it?
Yes, I got it. I got it. Thank you.
Do you get it, guys? Whose hand is up? Ask.
It's mine. I just wanted you to please explain again. One
Oh, what's your
can
name?
Khalifo.
Klalefo. Nice
Can
name.
you please give me an example or scenario where zero does not make sense or it's not meaningful?
Okay, let's go to the okay. Let's go to interval, right? All right. Let's look at temperature, right? If you look at temperature, do you agree, Klalefo, that temperature is it's a quantitative,
Yes.
right? So if temperature is quantitative, then what type of measurement scale will you give temperature? Interval, right? So then temperature, the difference between temperature make the difference between 100 degrees and 90 degrees is the same as the difference between 90 degrees and 80 degrees. Do you agree with that?
Yes, I
So
do.
that's the first property. That's the first property that temperature example make it an interval, right? There is no meaningful zero. 0 degrees, zero. Now put zero in temperature, right? Does zero for means there is no temperature?
No. Or hmm.
Does zero mean it doesn't mean there is no, like, if the temperature is zero, it means it's cold. It doesn't mean there is no temperature. I'm not sure whether my English is putting this.
Oh, okay. Yeah, no, I hear you. I understand. It's a bit hard to explain.
I know it can be very much confusing. 0 degrees does not mean there is no temperature. Zero is a temperature. There is no natural zero. So you can't have zero temperature and the meaning of it say there is no temperature. But everything in ratio, if you put a zero, somehow find it's some sort of natural state that if something is of zero, it means that this is this, right? You get it? Thank you.
Yes, I do now.
All
Thank
right.
you.
Thank you. Any questions, guys? Any more questions? Okay. Now I'm gonna give you guys an exercise that I'll want you guys to do it at home before we go to chapter 2, right? I'm gonna put in the chat. So this is a game, right? Every time we'll have our sessions, I will give you guys a game just after every chapter, just to make sure that you guys are following. So I'm gonna give you guys a Kahoot homework game. Kahoot. Do you guys know Kahoot? So this is a game pin. Game pin. Um, on your this is your link. Now I'm giving you guys a link to the game. All right. So when you find time just after our session, then please do this. Just as an indication to me that you guys are following and you understand whatever we touched on in our chapter one, right? So this game, these questions that you'll find, they are only going to be based on chapter one and a bit of chapter two, but we're going to do chapter two just now. So I'm giving you guys like 4 minutes to go drink water, go to the toilets and come back. Then we do chapter two. How many minutes do you how Bulelwa, how many minutes must I give them?
Whatever you're comfortable with.
How many minutes do you guys want? Five? Is five enough?
Can we have 10
Yes,
to
sir.
make
5 is.
it's
Let
a
me give you
100%.
10 because
yes.
I'm having a good day today and you guys are very much interactive to this session. I'll be generous and give you guys 10.
Thank
Thank you,
you.
sir.
All right, cool. If you back, just give me a thumbs up, right? Okay, I'm guessing everyone is back now. Uh,
I think so. I see so many thumbs up.
yeah, yeah. Okay, cool. So now we're gonna be looking at chapter 2. Now, I'm sure by now we all understand the terms we use in stat, the notations we use. Now, chapter 2 is based on descriptive statistics, which is mainly based on understanding of just the tools we use on analyzing the data, right? How do we describe the data? Now you have this qualitative data, you have this quantitative data, you have this ordinal variable, you have this ratio variable, you have this discrete variable or continuous variable. Now, how do you then quantify? How do you then make some sort of nice visuals from the data that you have? It's surprisingly that a lot of us are data analysis. Some get paid for it. Some don't know that they are data analysis. Some do not get paid for it, right? I'll make an example. So, so with that, I always fail when someone says, "Nah, I don't want to do stats. Stats is hard. I don't understand it," and all those things, right? Now, with that, I'm like, but everyone is a data analysis, and you can only be a data analysis through understanding statistics. Now, some people get paid for being data analysis, some don't, and some don't even know that they're doing a data analysis, right? For example, I'm sure each and every one of us here have asked a girl out. If you are a male, I mean, females also nowadays do ask girls out. But yeah, um, also, if you're a female, you've been asked out by a male, right? So you don't just say hope. You don't. A guy don't just come to you and say, "We're going out now. We're going out today." Right? A stranger doesn't just come up to you and say that. Am I right, Hope? Are you Hope? Are you back?
Yes, I'm back. I'm listening.
Yes. So I'm correct. A stranger don't just come to Hope and say, "Hope, I'm taking you out now," right? A guy,
Yes.
a friend, anyone, before they take you out, they will ask you, "Are you available on this day? Um, are you busy? What's happening?" Right? So there will be some sort of data collection that will happen between you, the two of you guys. Then from there, there'll be a conclusion whether you guys go out, yes or no. Am I correct? Hope?
Yes,
Ye-
you're correct.
Yes, right? So that's number one. So we hope what you've just done there with those interaction of questions and answers between you and the person that's asking you out is some sort of data collection. From that data collection, you will then sort of make a conclusion based on that. So what you're doing there, you're doing a very good job called data analysis, but you just don't get paid for it, right? That's one example of it. Another example is that if another example of this is the case where you want to go to the mall, right? You're driving. There are different routes to go to just one mall, but you'll always choose a route that has less traffic, a route that is has short distance. Now, what you're doing there, my sweet angel, is called data analysis. But it's just that there's no organization or anyone giving you money for that. Right. So that data analysis. Now let's go to chapter 2. Now, in making your analysis or your conclusion, you want to be precise. you want to be sure that the route you're using to go to the mall is the most accurate one in terms of less traffic, in terms of being the shortest distance. You want to make sure that the decision you're making in going out with this guy is out of your best interest, right? You don't want to go out with the guy on first date and you find yourself paying for the bill, right? Rather split the bill, right? So you see, you want to be precise. Now, let me teach you how to be precise. Let me teach you how to make good data analysis. Let me teach you skills how to quantify and visualize your data analysis. Let's go to chapter 2. So entire screen, which is screen 2. Right. Sampling methods. Right. Let's look at sampling methods. When selecting a sample, right? Okay, before we look at sampling methods, Busisiwe, why do we need a sample in general? Why would you need a sample? Busisiwe, are you there? Are you there? Okay, anyone? Why guys do we need a sample? You remember from chapter 1 there was an instance where we have sensors and those problems, da da da. Why do we need a sample? Why don't we just use the whole population? Yeah, what's up?
Would you say either your group is too big that you need to measure, or it's inviable? It's not a viable solution to, like, it's too expensive or something like that, to do the entire census on the entire group.
Okay, I can take that. Um, do you have okay, no, let me not ask this way. So let's just say, what's your name? What's your name?
Sorry, it's Reynard.
Reynard.
Yeah.
Reynard. Reynard. Listen,
Yes,
buddy.
that's
Listen, buddy. You have a couple of money in your bank and you want to start a business, right? Let's say you want to start a business of selling airtime, right? Now, out of that business around your area, now for you to sell airtime, obviously, Reynard, you want people to buy your airtime, right?
correct. Yes.
Okay, cool. Now, Reynard, you want people to buy your airtime, then you want to sell the airtime that most people you want to sell the airtime which is of reference to the service provider that most people use around your area, correct?
Okay. Yes, makes sense. Yes.
All right, cool. Hence you'll make more sales. Okay. Then is it possible that you go to each and every household in your area?
Yeah. No, that would not be feasible. It would take too long, and yeah, so it won't be possible.
Then what do you do then? Because you want to sell the item to everyone here in this area, but you can't go to each and every household. What do you do then? Because
So,
you want to ask people, right? To understand which service provider is mostly used around your area, you want to ask people what service provider they use, whether it's Telkom, Cell C, MTN, right? Now, you saying me that it won't be visible to go to each and every household to ask these questions, then what would you do then? Because you want to start this business. What would you do, Renan?
I would probably go to a select few in, I don't know, like block is, create like sections and get a few in each section, not everybody in a section or something like that. Just, yeah, it's you have an overall sort of
Let me
view.
just
Yeah.
Oh my friend, let me just let me clap hands for you. Yes, right. That's correct, right? We designed as statistical gurus a solution based on the information we want, um, of the population, that if it's not visible enough to collect information based on the whole population, then rather look for the sample. But you need to make sure that your sample is sort of a good representative of your population, because at the end of the day, you don't want to sell these airtimes to just a few that you've asked questions, but you're selling to the whole block, right? um, so it rather find a sample. A sample should be a good representative of the whole population, right? So that's why we need sample. From understanding why we need sample, let's then teach you how to get this sample. There are different types of sampling method, right? Now, this bias here means that you don't want to select a sample which is not a good representative of your population. Because at the end of the day, you want to conclude based on the whole population, right? There is something referred as a sample frame or a survey frame. What is that? This is the actual set of units from which the sample is chosen. Example, if you are interested in finding out what proportion of South African farm workers earn less than the stipulated minimum wage, you select your sample of hundreds as follows. Now, what I want you guys to understand here is that you are interested in finding out what proportion of South African, all, right? All South African, every farmer in South Africa, every South African farmer, worker, you are interested in those that earn less than the stipulated minimum wage, right? Now, I mean, it's not visible, or it's very much impossible for you to go to each and every farmer in South Africa. So what do? You select hundreds, right? Then what do you then do? Get a list of employees from these 100 that you've selected. Get a list of employees from a local farm. Alphabetize the list and select the first 100 men. Are the population and sample frame the same? So this is the question I'm asking you guys. So if you look at the population and the sample frame, are those two the same? You have the answer already, but I want you guys to explain to me why is the answer no. Are the population and the sample
Can you
frame the
please?
same?
I was asking if you could repeat the question.
So you've got these you've got this question where you are interested in the proportion of South African farm workers that earn less than the stipulated minimum wage, right? But since you can't go to each and every farmer in South Africa, you then select hundreds, right? Out of the 100 that you've selected, this is what you do. Get a list of employees from a local farm, right? Alphabetize the list and select the hundreds men. Are the population and sample frame the same? No. The population is South Africa, right? The sample
Yes,
frame, yes,
100
Hope.
men. No, I was just answering.
Okay, yeah, answer me.
The population, it's South Africa, and then the sample, it's the 100 men.
Yes, from those 100 sample farmers you selected, right?
Yes,
So that's a sample frame. These two things are not the same, right? So
yes.
don't confuse a sample frame and the population. Okay. Now let's look at the population. Population is from that example, South African farm workers, right? Different areas, men and women, right? Let's look at the sample frame. The sample frame, you looking at only men. so you're selecting. So a sample frame is where you are selecting your sample. It's the frame where you're selecting your sample, right? And you're only looking at only local area. That's also another frame that you made for yourself, right? So a sample frame can only come from the population, but it can't be the same as the population. Okay. Now let's look at this. Men are generally stronger than women. Maybe they are paid a different rate from women due to more physical challenge work, right? Maybe the owner of the local farm is generous and pays a good wage. Maybe the kind of farm work requires skill, and so the workers are paid more due to the skill requirements. Guys, I want to make clarity on this. What are you interested in? You are interested in finding out what the proportion of South African farm workers earn less than the stipulated minimum wage, right? Then when you decide to collect a sample of hundreds, right? You're not interested in females earning less or men earning less. You interested in South African farm workers. Now, your sample frame, you then decide to only look at men. You only decide on only looking at the local area. Now, your sample frame is some sort of bias because it doesn't entitle your whole possibilities of the entire population, right? So it becomes a problem when you use your sample frame to take your sample from, then conclude based on the whole population. Because at the end of the day, you want to sell your airtime to everyone, Reinhard, or you want to know the information of those who earn less, the minimum wage in South Africa, right? So it creates problems. You're making conclusions, which is referred as being biased. You don't want that, right? Now, how do you avoid that? We look at two types of sampling methods. There's a type referred as a probability based sample. There's also a type referred as convenience sampling, right? Now, a probability based sample, this is a type of sampling where everyone has an equal chance of being sampled to be on your sample space. Let me repeat this. If, let's say, you're doing a study like Raymond want to sell airtimes around his block. Good initiative. He saw that there can be a market value, a market share of him selling airtimes. He can make money out of that business around his block, right? Good. Now, for Raymond to sort of be in good terms in making more sales, he needs to understand that he needs to sell more airtimes of the service provider that is of very much evidence of use around his block, right? Now, for him to do that, he needs to make sure that his sample size that he will collect the data from is of a very good representative of everyone in the block. Now, the one way he could do that is to choose people at random, not just ask if his friends, what service provider are you using, what service provider, just 5 friends, then decide on those 5 friends. He asked that I'm gonna sell MTN airtime because my 5 friends are using MTN, right? He needs to do some sort of um a probability based type of sampling where you randomly choose people to ask this type of question. Why is that? Because at the end of the day, you want a good representative of the whole block, and you want to make sure that he sells more airtime of the most service provider that is being used around his block, right? So we then have something referred as probability sampling. That's a type of method he will use, where this method is saying everyone around Raymond's block have an equal chance of being interviewed, right? Um, so that's when chance means probability, right? So that's by virtue of that, we then look at probability based type of sampling. Under probability based type of sampling, what's happening? Is it me or the screen? Uh, okay. Can you guys still hear me?
We can hear you, but we
Yes,
can't
we
see anything on your screen.
Oh, you
can.
can't see now.
Yes, we can see.
We can see now. Oh, it's gone.
Now, not now.
Oh, okay. Sorry about that.
Sir, I can't see anything.
You will see just now, my angel.
Now.
Can you see now?
Yes, sir.
All right, good.
Yes.
So guys, I want you guys to take you guys slowly by slowly to understand the importance of everything that we've covered and why we needed to cover that before this and all that, right? So I mean, please bear with me if maybe I can be a bit slow. Time is not an issue here. My absolute best interest is for you guys to understand each and everything I talk about, right? So under probability based sampling, you have something referred as simple random sampling. You have something referred as stratified sampling. You have something referred as systematic sampling. Then you also have something referred as convenient sampling, because these probability based sampling, sometimes they can be also be of expense. It can also take time. So you then opt to use something referred as convenient sampling. Under convenient sampling, this is a sampling method in which you use people, if you're talking about people that are sort of readily available to you of used, right? Then you talk of quota sampling. Okay. Then let's look at simple random sampling. A simple random sampling, what is that? This is a type of sampling in which each sample of a given size n that can be drawn will have the same chance of being drawn, right? This is probability based type of sampling. This one is called simple random sampling. Let's look at an example. Picking the winners of 3 prizes, right? So what do? You have a bowl, you write each person that has entered the competition name on a piece of paper. You put those name in a hat or in a bowl. You shake the hat, you select the 3. What you did there, you will select the 3 randomly, right? You don't know who will win, and you sort of shake the hat or the bowl. Then you really don't have a clue. You've mixed up the names, you've done everything at random. Everything was just randomized, right? Let's look at another one. Okay, another example. You look this for yourselves. These are Excel questions that steps. These are Excel steps that you sort of can use, and in terms of finding random numbers out of any scale you want, right? Let's say you want to find random numbers um, out of a scale of 0 and 1. You then say equals to rand. You put these 2 brackets, then you'll have random numbers from 0 to 1. You won't have a number which is less than 1 or greater than 1, right? So if you, let's say you want the numbers between not 0 and 1, because maybe you're interested in numbers between 1 and 5, you say rand between 1 and 5. That's how you do it. I mean, you have the slide, you can just go through these examples, right? That's how you use Excel. Now let's talk about the advantages and disadvantages of using simple random sampling. The advantages is that simple to apply for a small population. Now the disadvantage of it is that it can be time consuming. Maybe not all items can be listed, maybe not all items can be found, right? So it somehow become kind of impossible, right? All right, then we have under probability based sampling, we also have another type of sampling which is referred as stratified sampling. Stratified sampling strata Now, from your sample frame, right? From your sample frame, you divide your sample with something called a stratas. From those stratas, you then select your sample, right? So these are items. So your strata is these are items in the population that are grouped according to some characteristics. Then from that structure, you then use a simple random sampling within that structure. Then the number that's selected from each stratum is proportional to the population, right? So what does this mean? It means that you understand that for you to randomize this, it's going to be really difficult, time consuming. It might happen that I don't cover everyone within my sample frame and stuff. So what you do, you choose your sample frame. Within your sample frame, you divide your sample frame within groups, which these groups will be called stratas. From these groups called stratas, that's when you now do the simple random sampling, where you select those people or those items of the same character that you'd want to be in your sample space, right? That you talk of stratified sampling. Let's look at this nice example here. In a study focused on people's opinion to road safely, road users were divided into 5 groups. What do we call these 5 groups, guys? These
The
5
stratas.
groups. What? What do we call these 5 groups? Stratas.
The stratas.
Yes, yes. Based on their mode of transport. So people were divided into these 5 stratas, right? So you've got 5 different types of mode: is taxi, car, on foot, or other, right? Now the proportion of those people that said they prefer a taxi was 42%, a car 22%, 19 bus, on foot 11, then 6 others, right? So note this: mode of transport is definitely an important contributor to a person's opinion to road safely. Therefore, grouping by mode is suitable. Now, this example, it somehow shows that, right? If a stratified sample of 400 road users is to be selected, now you've got a sample size which is 400. How many people should be chosen from each group? So you're doing a research, you're saying your sample size, you want it to be 400, right? I want to share a whiteboard here just to do some nice quick calculations. If we can. Uh, all right. All right, cool. Let me share. Just give me a second. All right. So what do you want? You're given 400, right? This is your n, your small n. This is your sample size. Can you guys see my screen? I'm writing on it.
Yes,
No.
yes, we can.
So we can all
Yes.
see the slide.
You can't see color red.
We can see it.
We can
Oh,
see.
We
perfect.
can. We can see
Okay,
it.
perfect. So you deciding you want to do a survey. You're saying no, I want to do a survey using probability based type of sampling. What type of probability based is stratified sampling? Now from there you know that, okay, I want my sample size to be 400, right? Now the question is, how many people should be chosen from each group? How do you find that? You know that probability or proportion is R. The formula for proportion is R divided by N. Right? Now, in this case, you've got your proportion. I mean, sorry, yeah, this is big N, population, right? I don't want to make confusion. Right? So you already given your proportion. They want to know out of your population of your sample size of 400, how many of these people out of these 400 will be using taxi as the mode of transport. So you're given your proportion as 0.42, right? So you want to find this R, which is the your interest. These people that you want to know how many of them are using taxi as their mode of transport. Then you multiply by your 400. What is the answer? What is 0.4 multiplied by 400? You tell me. I'm using a mouse here, so never mind my handwriting.
160, sir.
160.
Yes.
Yes. So what does this mean? What does 160 mean? It means that out of the 400 that I have or that I'll select, 160 of the people will be using taxi as the mode of transport, right? To find out how many will be using the car, you do the same thing. You put 22% multiplied by 400. For the bus, you do the same thing, right? Okay. Right? This is how you do it. So 0.42 multiplied by 400, 168. Do we have a question? Yes? Question? Someone raised their hand here. I can't see who.
It's Sibanda.
Sibanda. Sibanda. Okay, let me just lower your hand then if you're not gonna ask. Yes, Sibanda, do you have a question? Okay. All right. So this is how you do it. This is how you do it. So 0.42. Now, what I was interested on was showing you guys why do we multiply these two. It's because this comes from the proportion what formula, which is equals to R divided by your population. Then, because we're interested in R, the number of people who are using different types of mode, we then need to multiply by N here to make are the subject of the formula, right? So this is how you do. If you add all these things, should add up to 400 because that's your sample size. We also have something referred as systematic sampling. Now, this type of sampling is where now you're looking at choosing your sample based on a value called kth term, right? How do you find the kth term? K is equals to n divided population n divided by your n. Now, the step one you need to use is number each item. Step two, randomly select a number to get the first item of the sample. Then choose every kth item till the sample size of the required size, right? Let's put this into context. An example, a car manufacturer wants to check the size of the particular part that is being made. 200 were made today. The manufacturer wants a systematic sample of 30. So 200 were made. What is your 200? 200 is your population. What is your manufacturer wants a systematic sample of 30. So 30 is your sample. Now, you want to use a systematic sample to choose the manufacturer wants a systematic sample of 30 to choose this 30, right? You want to use a systematic sample. Now, the manufacturer will select what? Every part of the sample. How do you do that? You find the K term. So you'll need to always round. Okay, you need to always round this up to 7. The reason you're doing that, it's because um you can't have a k term which is of decimal. You can have only have a whole number k term, right? What does this 7 mean? It means that you will select every out of these 30, out of these 200 parts that you'll be selecting your sample size from, they are numbered. So you'll select every 7th car, right, to be on your sample size, which will be of 30, right? Okay, now the question is, suppose the manufacturer starts with the 4th part, right? The 4th part, that's where you'll begin selecting your cars. What is the number of the 3rd part to be selected? Now, how you do that is, so you've numbered all the cars that were manufactured on the day, from car 1 up until the last car. Now you need to have your starting point. Your starting point in this case is 4, right? 1, 2, 3, 4, 5, 6, 7. You select again. So your K you calculated as it being 7. So 1, 2, 3, 4, 5, 6, 7. You select. So 4 and 11, car 4 and 11 will be on my sample size. 1, 2, 3, 4, 5, 6, 7. 18 will be on my sample size. So 4 and 11 and 18 are on my sample size up until I have 30 cars. Then I'll be done selecting cars, right? We also have a type of sampling referred as quota sampling. Quota sampling is referred as convenience sampling. How do you go about doing a quota sampling? You identify characteristics of interest, then you decide on a category. That's step 2. Step 3, you then choose a quota and a sub-quota. Then 4, you collect the information from somewhere convenient till quotas are obtained. Let's look at a nice example. A company is marketing a new type of soap and want to know how potential customers might react to it. Quota sampling can be used. Step 1, important characteristics. You're looking at gender and age. This is what you choose. You want to look at males and females. You want to look at age of people which are under 30 and 20 to 60 and over 60, right? That's step 1. You identify your characteristics of that are important to you. Like that example of Reinhardt, you're only interested in people who have phones, right? You don't want to ask a question to someone who doesn't have a phone, right? Because that's not your customer of interest. Right, step 2, decide the categories. This can be done using a table. There are 6 categories: males under 20, females under 20, males 20 to 60, etc. That's step 2. Step 3, choose quotas and sub-quotas. Total sample size, how many go into each category. This number can be chosen in various ways. Often equal numbers are chosen for each category, right? Out of the male that you want 15 females, 15 males which are under 20. For 20 to 60, you want 30. So all these things you decide for yourself before you do the sample, right? Step 4, go somewhere convenient to collect the data. So whatever you've decided, you then go where it's convenient for you to find this information you're looking for, right? You can't go to a place where there is no tower. You want to sell airtime. You can't go to a place where there is no network tower. It means that people don't have phones here. So why would you want to ask them what, you're wasting your time. So you want to go where it's convenient to you, that you'll find some information there. Now, the disadvantage of that is that the interviews can be a bit biased. Now, why are they biased? It's because for some reason they might not represent the whole population, and that can result in having conclusions which are of bias, right? All right. Now let's look at another session. Graphs. Let's look at graphs. We're almost done, right? So can you see my screen? I'm showing a new slide now.
Yes, we can.
Yes.
All right, perfect. So let's look at different methods that we use in terms of describing our data, right? We've got all this data, we've done the sampling method. It's either we've done the probability based or we've done the systematic. Now, how do we describe, how do we visualize our data, right? We've got something known as line graph. Line graph is mostly useful if your data is of a time variable, right? Then you will use line graph. Otherwise, there are other different types of graphs you can use if your data is not data which is collected over time, or it's a variable that doesn't represent time, right? You have something referred as a bar chart. A bar chart, you see these bars. Okay, it's either you have a simple bar chart, a component bar chart, or a compound bar chart. Simple bar chart. Simple, you can see it's just, it shows this is as your x variable. Your x variable, it comes here, then your y variable sales which will come here. Now your y variable are always influenced by your x variable, so your y variable change as x changes. X can't be influenced by y, right? That's why you've got your weeks here and you've got your sales here. This is referred as the dependent variable. This is referred as this is a dependent variable. It depends on an independent variable, which is your x variable, right? Where your y is also referred as your response variable. You also have compound bar charts. A compound bar chart is a type of a bar chart which have different sort of layers within each bar chart, as you can see here. Now, this tells a more delightful or more information rather than just having a simple bar chart, right? Again, it being generated from this data here. You also have something referred as a multiple or a compound bar chart. Now, this is a type of a bar chart where each component is represented by a sequence of bars. Comparisons between the trends of compounds is possible, right? So this is where now within a single bar chart, you also have some sort of other bars. Then those bars are then, that just group will be referred as a compound, right? Okay. We also have something referred as a Pareto chart. Pareto, Pareto chart. This combines a bar graph and a line graph, right? Now, a bar graph, this is where you draw in descending size of order. You can see that from a bar graph. You can also understand in this way, this chart is visually depicts which situation are more significant. All this you can see from a bar graph. Now, a line graph from a Pareto chart shows the cumulative totals, right? Let's look at an example of a Pareto chart. This is a Pareto chart. This is the line graph that shows a cumulative. It keeps on adding from the previous, right? Meaning this is your first value is 40. To find 75, you add from the previous value uh, and the current value, which is 40 plus 35, this is 75. You go so on in finding other points as well. It's cumulative, it keeps on adding on, right? This is a Pareto chart. Okay, right. You also have something referred as a pie chart. A pie chart is a circle divided into slice or component. This size shows how much it contributes to the whole, right? Pie chart, this pie chart is, if it needs to add up to 100 to 360 degrees, that's a full circle, right? So how do you find this percentage? you use this formulation here. Then from this, you then go and draw your what? Your pie chart. Right? Okay. You have also have something called as a dot plot. A dot plot, this graph shows a quantity is for quantitative data, shows patterns in the data set, good for small data sets, right? What do you go about drawing this dot plot? You need to find the minimum and the maximum values, draw a suitable section of the number line, mark dots at the position of the data points. If there are data points with the same value, stack their dots on one another. Let's look at a nice example of this. So you've got a minimum value, which is 4. You've got a maximum value of 10. You have the number line of which you decide which numbers do you want to put here, which will be suitable for your own data. 3 up to 11 is what we drawn. Then you've got 4. 4 is the only number that's here. 5 is the only number that's here. But if you look at 7, it means that from this data, there are 2 sevens. 1, 2, right? That's called a dot plot. You can draw these graphs, these beautiful graphs using Excel, right? Go through these slides to just understand how would you then go about drawing these graphs using Excel. All these graphs, right? Then you have something referred as a stem and leaf plot. Stem and leaf plot is used for quantitative data. It shows the pattern and the shape of the data, right? How do you go about drawing a stem and leaf? You arrange the data in ascending order. You choose the stem and leaf, and you choose the stem and the leaf units. Make a key, then plot. Let's look at how you can actually do this. You have these numbers, right? 3, 37, 11, 22, 16 up until 17. Now, the first thing you need to do is to make a key. You can see that these numbers are of 2 units. You've got 1, 6, 6, 1. They are of 2 units. 3 can be 0, 3, right? You make a key. 1, this line. So this is a stem. These are leaves, right? You've got 2, 2 as a leaf. This means it's equals to 12. You put your stem as 0 to, so you look at your highest single units from your given number. In this case, your highest was 6. So that's why you've got 0 up until 6, right? Then you then put your leaves. Your leaves, if it's 0, 3, it means there's a 3 here. There are 2 3s here by the look of this. So it's 3, 3, 3, right? So how you do that in Excel, it's explained nicely here. Just go through that. Back-to-back stem and leaf plot. What does this mean? It means now your stem is in between. Let's look at an example. You are in a diet, but will be going out for breakfast with friends. You can choose from 2 restaurants. Which restaurant would you choose? That's the question. Compare 2 data sets, right? The fat content of 14 breakfasts from each restaurant is on the following slide. Let's look at that. So this is the data. This is another data. You do the same thing. You do the key for restaurant 1. You do the key for restaurant 2. This is how you'll find your back-to-back stem and leaf. What is this? This is your stem. This is your leaf for restaurant 1. This is your leaf for restaurant 2, right? Let's interpret this. The values fat content from restaurant 1 seems to be smaller than those restaurant in 2. So you should go to restaurant 1. You are more likely to pick a breakfast that has lower fat content because you're on diet, right? All right. So I've now explained to you different type of visualization that we use in describing our data, whether it's quantitative data or qualitative data. Okay. Then now, let's see what we need to now then look at. Right. Now, we're going to look at some nice sigma and subscript notations, right? So if you look at this now, this is called the sum. Now I'm teaching you guys how to write instead, right? This is called the sum. This is called x1. This is variable 1, variable 2, variable 3, variable up until variable n. Subscript, this is a subscript, means first value. Subscript 2 means second value, up until n, which is the nth value, the last value. The summation of xi, what does this mean? Summation means you adding, right? x1 plus x2 up until xn. X squared summation x squared 1 plus x2 up until xn. Let's look at an example. 4314. Summation of this is equal to 4 plus 3 plus 1 plus 4 is equal to 12. Summation of x squared is 4 squared plus 3 squared plus 1 squared plus up until, right? Okay. So please note this. This is very important. You should note this. This doesn't mean this, right? This means that you're adding all this and you're squaring. This means that every variable, it's squared, you square it plus you square the next variable and so forth, right? Frequency distributions, right? Let's look at frequency distributions and related graphs. Frequency distributions. So this is where now you're talking of group data. Then you look at frequency distributions. Now, frequency distributions comes from group data. It's either you have discrete data from quantitative data. From that descriptive data, you can have group data. From group data, you then create something referred as a frequency table. This is a frequency table. You will have class limit. You will also have a frequency. This is grouped. This is grouped. So 1 is to 5, that's the first class. 6 is to 10, that's the second class. 11 is to 15, that's another class, right? Okay. You need to understand that if you add all these frequencies, you will sum up to your sample size. So if we add 5, 8, 6, 8, 5, 4, we'll add up to a sample size, right? How do you construct that frequency table? This is very important now. The first thing you do is what? Find the range. What is the range? Range is the maximum minus the minimum, right? That's your range, right? Step 2 is to determine the number of classes, right? Step 3 is to, I'll teach you how to determine the number of classes. This will be our last slide, right? Um, then step 3 is to determine the class width. Then step 4 is to choose the lower value of the first class. Then calculate the lower values remaining class. Step 6 is determine the upper values. Then step 7 is to record your frequencies, right? Let's look at this example here. This is what I call discrete variable, right? These are just numbers. But what we're interested in is we want to group these numbers so as to conduct our construct our frequency table. We can only construct a frequency table from discrete variable, and we then make those discrete variables to be group data. We group these discrete variables. The first step, calculate your range. The range is what? Maximum minus minimum. So our maximum is 88 minus 7, which is going to be 81, right? Now, the first step will help you in denoting or determining the number of classes, right? Determine the number of classes denoted by K. That's your step 2, right? This is what we do. Use something referred as the Sturge rule to find K. Now, the Sturge rule, what does the Sturge rule say? Rounded up value of 1 plus 1.44 ln n, right? So 1 plus 144, Lin, what is 50? This is the sample size of the samples that I have. Then you'll find that it's going to be 6.63. We always round this number up, right? So the number of classes is going to be 7. These are classes, right? 1, 2, 3, 4, 5, 6. In this frequency table, you only have 6 classes. In our frequency table that we'll create out of this, we'll have 7 classes. Right? Now let's decide, how are we gonna what is the difference within these different classes now, within these 7 classes. Then we go to step 3, right? Determine the class width denoted by C. This is the formula we use. C is equal to range over K. We always round this up again. So C is equal to 81 divided by 7. Remember, where did we find this 81 from? Step 1. We always round this up. What does this mean? It means that, okay, I'll show you what it means just now. Let's look here, guys. Okay, before we look here, step 4, 7 is the smallest value, so let the lower value of the first class be 6. So we look at the minimum value, then we take the number less to that value to denote as our first value within our class, the first class limit, right? Now add 12. Why you add 12? Because that's our class width, right? That's step 5. Now what will be then our upper? The upper class value will be 1 unit less than the lower class limit of the following class, right? So this is, what do they mean here? I'll explain just now. Determine the frequency now. Now 6 comes from the lower number from the minimum. 17, if you add 7 plus 12, you get this, because when you subtract 17 minus 6, you need to find 12. When you subtract 29 minus 18, you need to find 12. Why? It's because the class limits need to be the same in all these class limits. You need to make sure that is always the case, right? Now, I mean, you can't have, so what does this mean? This is every number that is greater than 6 but less than or equals to 17. You look in this table, this nice table that you have here. Guys, let me repeat this. What you need to count, it's every number that is greater than 6 but less than or equals to 17. You come here. How many numbers that are like that here are greater than 6, less than or equals to 17? All right. There are 5 of them. You count them. Let me just select one. This one is included. 17 is included. 7 is also included. Right? There are 5 of those numbers that are of that instant in this data that we have. Right? I mean, 17 can't be included here because it's included here. So you start from 18. That's what step 6 is referring to. All right. Okay, so we've done that. Okay. So you can also do the class frequencies using Excel. You can just go through that using these PowerPoints that have already been sent to you guys. Right. Now, from a frequency distribution, a number of things can be calculated from that frequency table that we've just constructed now. A number of things can be calculated. You have something referred as a class midpoint. You also have something referred as a cumulative frequency. You have something referred as a relative frequency and a relative frequency percentage. Class midpoint, what does a class midpoint mean? It means that this is the middle value of the class interval. Cumulative frequency, this is the value in which a sample that are less than or equals to the upper class boundary of that class. Relative frequency, this is a class frequency of a class relative to the sample size, right? You also have a percentage from that relative frequency. Let's look at this example. So you've got this example. From that example, you create what? You create a frequency table. From that frequency table, where is this frequency? This is the frequency table you've created, right? From this, you create a frequency table, class limits. I've shown you guys how to do that. Then you have class boundaries, right? How do you create class boundaries? Step one, you say 37.5 plus 41.5 divided by 2, right? Step two, then you find the midpoint. So to find the midpoint, you need to say 38 plus 48 divided by 2. You find this midpoint. A class boundary will subtract a 0.5 from the lower limit and add a 0.5 from your upper limit, right? Always. Okay. Okay. All right. So the Excel stuff, please go through it because I've really tried to explain it step by step in the slides. So just make sure that you go through them, and also with relevant graphs you can draw from the Excel using Excel from the frequency table. Also go through these Excel slides. All right, so your data sets from that frequency table can either be of bell-shaped, rectangular form, bimodal, positively skewed, or negatively skewed. Now, how do you see that from a frequency table something is of bell-shaped, rectangular or uniform, or binomial or positively skewed? Right. A bell-shaped data is somewhat a type of data which is of this shape, right? So what does this mean? It means that most values occur at a middle section, fewer and fewer in either direction. Okay. You also have a rectangular, also referred as a uniform. This is a shape occurs when all values in the data set occur approximately the same number of times. You also have a bimodal. A bimodal, this is when two distinct subgroups with different values give two distinct peaks. You also have something which is positively skewed. From that frequency table, I'll show you just now how do you see. Also known as skewed to the right, right? What does this mean? Most values occur in a lower end of the scale with outliers on the upper end pulling the tail of the graph to the right, right? You also have negatively skewed. The data is referred as being negatively skewed if most values occur in the upper end of the scale with outliers on the lower end pulling the tail of the graph to the left. Okay, so let me show you now. How do you tell this? Can you guys see the frequency? This is the frequency. If you look at the frequency, what's happening? 5, 8, 6, 8, 5, 4. What's happening? Are these numbers increasing or decreasing? So 5, 8, 6, 8. If you were to draw this, will this be positively skewed or negatively skewed? Definitely not uniform, definitely not bell-shaped. It's either it's negatively skewed or positively skewed. Can you see that you have more numbers this side than here? So if you were to draw this, it will be more peaked to the left because at the beginning it's getting more numbers. So this, it's then referred as being positively skewed, right? Okay, so that's it for today. You can go through the other slides that I've created for you guys on your own spare time. If ever maybe you have some questions regarding this, let me just share my WhatsApp number on the chat. If ever you maybe want my so my WhatsApp number is 081 331 4300. Just in case you maybe want me to elaborate in some of the things that I've already gone through here, or else you've got some past papers that you'd want me to help you go through with you, you can WhatsApp me on this number. Then I'll be more than happy to help you. So in today's session, we covered the terminology, we've covered the descriptive statistics, we've covered the types of sampling, we've covered ways on different on ways on how you draw different graphs from different types of data, right? So thank you guys for your time to just avail yourself on a Saturday. It really comes with great gratitude to me. Hopefully, even next week, you guys will join me because next week we then going to be looking at chapter 3 and 4, which will be based on probability and probability distributions, right? So yeah, do we have any questions?
Yes, sir. May you please share your contact number on the chat because I
Yeah.
couldn't capture it properly. Thank you.
All right. Any questions or comment if not a
How
question?
can
Yeah.
we have the recording? How do we get access to the recording of this session in case you want to go through the material again?
All right. I think Bulelwa will then have to assist me with that. I think Bulelwa.
Thank you, Mr. Ngobo. Students, everyone who is invited and is in this meeting will have access to the recording at the end of the session. Maybe you can check it after 10 to 15 minutes. You'll be able to access it.
Where will we access it? That's
On your
the question.
chat. On your chat, ma'am.
All right. Thank
Yes, thank you. Can I also remind you to please complete the evaluation form? I also posted it on the chat.
Okay. Thank you for that. So yeah, hopefully this session was really insightful to some of the areas maybe that needed more clarity. And to me, it was really of helpful to also emphasize some of the things that sort of don't come as clarity to a lot of students that I help. So I'm really grateful that you also guys were very interactive in answering the questions. Let's keep it that way even for next week. Yeah, enjoy your weekend. Have a
Sir,
great weekend ahead of you. Yeah,
sir,
what's up?
I have a question. You said at the
Yes.
class, you said at the class intervals you always round up. So does it mean even if it's 0.4, it will be 7?
Angel, please repeat that again.
So you said at the class intervals you always
Class
round
limits. Class
limit.
intervals.
Yes, you
Yes.
always round up.
Where are
So
we? I'm
I
trying
think
to get
it's
there.
is
Here.
step 2 yeah. You
It's
always
here.
round up. Yes.
Yes, you
Yes.
always round up. Yeah.
Well, does it mean even if it's 0.4, it will be 7
If it's
or 0.4 or I
if
mean
you
6.4
0.4
or
yeah? Yeah?
I mean 6.4 or 6.3, it will be 7.
Yes. Yes. That's what rounding up means. It doesn't matter whether the number after a comma is greater than 5. If it's 6,4, we still need it as 7.
Okay.
Yeah. Because you know why? It's because you don't want to have a frequency table which have a lot of class limits. You get what I'm saying? A lot of class. So you're trying to grab you're trying to group the highest number of your variables as high as possible. You get what I'm saying?
Yes, sir, I understand.
Yeah, yeah, yeah. Any more questions, guys? I love questions. Okay, so I'm guessing we don't have any questions, but if you do have any questions, my number is on the chat. You can WhatsApp me at any given time. I'm a 24/7 guy. If you need me, you get me, right? So, or else, if maybe someone wasn't able to attend the session, I mean, be generous to share with them the video and invite them to our session next week, which is going to be on Saturday, same time, on Teams, same link. So be generous to give people my contact details as well, if maybe they might need my help. Okay. All right. Bulelwa, that's it for me. I'm not sure whether I'm leaving anything out.
Thank you, Mr.